and welcome to the Spatial Structures Movers and Shakers interview series, hosted by the University of Surrey's Spatial Structures Research Centre. My name is Mark Richardson, and today I'm joined by Sofia Colabella. Sofia is an architect and lecturer in architectural technology at the Faculty of Architecture, Building and Planning at the University of Melbourne. She co-founded Gridshell.it, a company specialising in the design and construction of special timber shells designed through advanced digital tools, low-tech construction techniques, and full-scale prototypes. Sofia's research interests include, among other areas, technologies promoting social equity and ecological sustainability, contemporary uses of ancient technologies, and digital design thinking and making. Sofia, thanks very much for taking the time to join us today and joining us all the way from Australia.
Hello, Mark. My pleasure, and thanks for having me.
No problem at all. It's a real pleasure to get to speak to you on the Movers and Shakers interview series. We start by asking our guests about the spatial structures community in your locality. And as I mentioned, you're based in Australia, so we'd love to hear more about your experiences there.
Yeah, I can tell you that the University of Melbourne for sure is a great place to be a researcher and connect with the industry and colleagues with similar interests. Consider that the first Hangai winner is in Australia is Alberto Pugnale, senior lecturer in architectural design in my faculty, ABP. Our chair in architectural design is Donald Bates, director of Lab Architectural Design, and also authors of Melbourne's Federation Square, among many other things. Stanislav Rudarski is a senior lecturer in digital architectural design and expert in parametric generative processes in architecture, complex geometries, and a lot more. And the IDD plus F, Advanced Digital Design and Fabrication Hub, which I am a member and co-founder, has allowed many collaborations over time with Trevor Cox, Lisa Iwamoto, Jenny Wu, and Theodore Spiropoulos, just to say a few. Most importantly, I am a member of the organizing committee of the ISS 2023, chaired by Professor Mike Shear and Professor Jane Berry from Swinburne and RMIT Mike Shear. We are all very excited to host and organize this event because of the long period of isolation, of course, but also because it will make it easier for us to connect with our overseas colleagues with whom many of us living in Australia have been collaborating over time, but also struggled during the last years.
Fantastic, thank you for that. And yeah, very exciting to hear about the preparations for the conference. I'm sure everyone watching that is very much looking forward to that. And we also ask our guests about their sort of career paths and career journeys. So perhaps you could provide us with an overview of your career journey to date.
Yeah, thanks. My career trajectory arose in my architecture practice and then developed through my PhD in architectural technology and innovative uses of small timber laths. This led me to investigate free-form large span spaces made of timber and active bending and acoustic sheds. I've also researched the use of timber through simple technologies in digital design and fabrication for affordability and homelessness, focusing on the role of timber-based products in the existing construction industry. As an active bending expert, I was also hired as visiting scientific partner at the Structural Exploration Lab at the EPFL by Corentin Fivet, Professor of Architecture and Structural Design, to investigate the reuse for structural purposes to show how materials with unknown characteristics and mechanical behavior can be used to design performative and innovative structures. As a member of the SHE Lab, that is the Sustainable and Healthy Environments Lab, I work across disciplines to connect my research inputs with cross-disciplinary innovation and on sustainability. And for the past 3 years, I've also taught across disciplines from architectural design to construction technology, both at the undergraduate level and postgraduate. Focusing on constructive alignment, problem-based learning, cross-disciplinary education, practice-based design, climate commitment, and with a focus on cultural values of local communities as well.
Superb. Thanks very much, Sofia. Lots of really interesting things happening there, and we look forward to hearing more about some of those in your forthcoming presentation. Before we get to that, we ask guests about research projects or papers you're currently working on. So maybe you could tell us a little bit more about that.
Absolutely. My last paper presents a theoretical framework for and pedagogical principles for performance-based design education on acoustics and structural behavior for a master design studio that I have been developing and co-teaching at the Melbourne School of Design for the past 3 years. For this studio, structural behavior and acoustics drive design education and engage students in modes of design thinking that circle performance-based design, model making, computational design, landscaping, and back again to design thinking. This is also the pattern of my research and teaching activities based on the exploration of the invisible components that influence the design outcome. I am an architect, by the way, so I'm very interested in that, which in the case of acoustics is way more invisible to the majority of people than even structures, which are pretty invisible. And on the reuse of waste in architecture, I'm now studying the use of clothes waste for tensile structures, mainly urban shadowing systems that can engender a variety of expressions as an artistic and problem-solving strategy to make small changes in the way people see recycling through different lenses.
Well, fantastic. Thank you, Sophia. That sounds like a pretty fascinating area of work. So thank you for sharing that with us. We're now going to move to the middle section of our interview, which is entitled Your Space, Your Structure. So at this point, I hand over presentation rights to Sophia, who will be presenting on a topic relating to spatial structures of her choosing. So without further ado, over to you, Sophia.
Thanks, Mark. I'm going to share my screen. Dedicated this conversation with you to the power of limits, which is the title that Doxy gave to one of his books, and to me is an overarching belief that limitations are not just restrictive, but mainly creative, and that's up to us. Unsurprisingly, Aboriginal vernacular small shells were made of timber sapling bent in place, clad with natural elements found on site. Shells and grid shells, being structurally efficient, are more sustainable than other types of structures and are one area of my expertise and passion. My PhD thesis tested and the hypothesis that socio-technical, environmental, and architectural gains could be achieved through innovative architectural and structural uses of small timber lats. At the time, I was still trying to understand what Ted Happold and Freya had achieved on one of the most iconic elastic grid shells in the world, the Mannheim lattice shell, with its 4,700 square meter covered area and only 4 layers of 50 by 50 millimeter hemlock. From an architectural perspective, the critical advantage of active bending has always been the chance of free-form shapes with easy-to-produce linear rods. Since my doctoral degree, I've been designing timber grid shells and acoustic shells by combining advanced digital tools and low-tech building techniques. Among the outcomes of my PhD, I co-founded GridShield.it, a firm specializing in design and construction of timber spatial structures. And my former business partner and I started testing bending structure at scale 1-to-1 in 2006. We started with physical models and simulations of the design of the construction process, focusing on how the constraints and the orientation of the flat lattice determine the final shape. At the time, this was a story of trial and errors, and we learned a lot from failures, of course. 2012 was a milestone for us as we had gained good experience in grid shell construction and also started developing digital tools for determining the final shape. This was a real-scale prototype proving the results of a form-finding tool written in Grasshopper by Daniele Lancia and Andrea Fiore to predict the final shape of a flat grid given the connections to the ground. It then became apparent that we had to flip the process and start from the architecture, so the final form, in a way to combine an optimal construction process with stability and the final shape. In this case, we worked with Gabriele Mira and Edoardo Pignatelli to develop a multi-objective genetic algorithm to discretize a generic surface into a grid of quads. With the netfish method, we optimized the orientation of the grid to minimize the lath curvature. And then moving away from that as an independent researcher and passionate about large span architectures and environmental awareness, I extended my studies to discarded materials. And in 2016, Corentin Fivet and I submitted a proposal for the first Biennale of Architecture in Lyon made of discarded fishing rods because of their large deformation when in use. The committee of the Biennale, of course, was enthusiastic, selected our proposal and asked us to design a pavilion to be showcased around the city. However, we discovered then that Swiss people are not so much into fishing, and it turned out that skis were the perfect locally sourced material, as Swiss people throw away thousands of skis each year. And from a structural standpoint, skis have great potential for use and structural components because despite using age, they maintain their high-level physical characteristics, high breaking strain, as well as low modulus of elasticity. And obviously, the inventory was not the easy part, especially because skis are often covered by patents and their composition and elasticity and mechanical characteristics are difficult to be determined. Once I defined the modulus of elasticity of each pair of skis, I tested possible shapes derived from a dynamic relaxation simulation. The shape we selected was then converted into a construction process that had to be simple and cost-effective. So we chose to use the simple technology of the block and tackle pulley system, which allows trading force for distance. That was a way to also retrieve an old and discarded tool from the past. Skis of different ages and types, of course, as you can imagine, had different stiffness and had to be optimized. However, the good thing was that with elastic grid shells, the geometric stiffness of the shell is not uniform as well. Therefore, the layout of the skis was designed according to the skis elasticity, compensating for the minimum radius curvature and the overall geometric stiffness to ensure stability and minimize deflections. Corentin Fivet and I, of course, didn't intend to propose people to build with skis, but we intended to show that we can design with uncontrolled components with a sufficient level of confidence in the structure, safety, and performance by working on structural efficiency and redundancy. The 36 square meter skis grid shell was made of 210 reclaimed skis. It was assembled and reassembled 6 times and with traditional tools and also generating almost near zero waste. It showcased the value of waste, thinking out of the box of our culture based on the idea that time is the most valuable resource we have. We acknowledged that designing with reclaimed materials implies a complete redefinition of the conventional structural design workflows. Most of the research-based subjects, design studios, and intensive construction workshops I developed over time take advantage of all these experiences. So as a practitioner, as a carpenter, and also as an academic, active bending also is useful for performance-based design education, focusing on structural behavior and acoustic in my case. These subjects tend to acknowledge the responsibility of architects to minimize the impact of natural resources and design for longevity. In these 2 cases, how to make things lighter and issues in technologies coordinated with Alberto Pugnale introduced students to design concepts of foam resistance to appreciate how different structural and construction strategies can shape design propositions. For the International Tongi Construction Festival, I led a team of 6 first-year students from our faculty. All teams were given the same number of polypropylene sheets, and from these panels, we cut strips that we bent into circles. We connected these circles on the floor and then pushed them up into the final shape. Using this simple trick of the circles, we had a double bending action with almost zero waste. I also use a similar approach to teaching at the master level. This is a design studio on architecture, art, and acoustics, where the concept of sound, noise, and silence become a vehicle to test students' architectures. I developed this studio to illustrate how structural behavior and acoustics can drive design education and engage students in evaluative modes of design thinking, from performance-based, model making, and computational design. Through several design exercises, such as the ones formulated by John Hudson, Water, and other sound tests, students become aware of the geometric relationship between architectural form and acoustic performance. Shell-like structures are recursively tested through listening experience and acoustic simulations to visualize sound propagation and critically listen to design space using ray tracing and image source methods. The inspiration for this studio and this teaching and learning activity comes from a summer school on acoustics, VPM, which I developed with my former business partners in Italy. Here, performance-based design is combined with a low-tech and low-cost construction system to allow students enrolled in the workshops to build an acoustic shell before the commencement of an international classical music festival. The design and computational processes and construction systems are developed to align with simple manufacturing process and to enrich the experience of musicians and the audience in a difficult environment of outdoor space. The overarching idea is to blend digital tools, the history of construction techniques, and prototyping to offer a different perception of design thinking and making. And I am concluding this presentation with Calvino's 6 memos for the next millennium. Structures are everywhere in nature, as much as in language, music, architectures, and more. Like Calvino, I've always been interested in subtracting weight, especially in a world facing global warming and decreasing natural resources, because as designers, I believe we must take responsibility for it.
Sofia, thanks very much for taking us through your presentation there, a whistle-stop tour of some really fascinating things. We covered lattice shells, grid shell structures, discarded fishing rods, the reuse of skis, and the relationship between form and acoustic performance, and also very interesting to see that in application to education, which you covered so well. So thank you very much for taking us through all of those things in such a short space of time. It was very informative and yeah, highly interesting. So thank you so much for that.
Thanks, Mark.
Let's move to our final section of the interview, because it's very pertinent actually to what you've just presented, in that it deals with questions around sustainability, and some of this you'll already have touched on. But what are your personal views with respect to the question of sustainability and spatial structure projects? How can sustainability be improved within our community and its outputs?
Well, so I believe that the concept of sustainability requires us to consider the long-term implications of design form from an economic, social, and environmental standpoint. And we know that there is no such thing as one solution fits all. However, when I look back to the great engineers of the past, they could translate building performances into the architectural language. And today we have powerful computational tools that allow us using fewer material by playing with the form of structures precisely as nature does. And the material in nature is the expensive part, while the shape is not. And to me, that's the most creative aspect of structural efficiency. And in terms of community and what we can do in our outputs, I think that we must address a long-term challenge, that is to reduce the environmental impact of construction, which implies a redefinition of our leadership role as researchers, architects, and engineers. And that's, however, not enough still without promoting economic incentives for sustainability. That means having new forms of cooperation between government, practice, and university, and engaging with policy, design, economics, and social impacts, in addition to our conventional research projects in architecture and engineering. And this also implies becoming more visionary, probably, as educators, and being able to scaffold our students' journey towards critical thinking beyond conventional ideas of what design and structural analysis are. That's the reason why thinking about fishing rods or skis can be a very good idea in some cases. Anyway, my take is that this is a teamwork and across disciplines with strong governance structures which should be able to support long-term integrated implementation. And if we don't go that way, we risk shifting one problem from one area to another, or creating social division and tensions that we don't want, right?
No, absolutely agree, and it's very interesting because it is as you allude to, a very much an evolving discipline with a lot of an interplay of a range of factors in it, which we've touched on in previous interviews. So it's really interesting to get your take on it there as well. And we saw in your presentation the excellent ski pavilion, which was a very elegant geometric example. So that's a wonderful example of sustainability in practice. But do you have any examples of other best practice that you've seen on recent spatial structures that you'd like to shout out or share with the community?
Well, probably it's not really recent, but I love how John Oxendorf uses two sustainable bridge types, a Roman arch bridge and a suspension bridge made of grass, which has survived for centuries, to illustrate successful and unsuccessful designs. And both are made of local natural materials through local craftsmanship. And as for the case of reclaimed skis, I'm not implying that we should design grass bridges or ski pavilions, but we should use these examples as a framework for considering the environmental impacts of our decisions. And I believe that history and nature provide us with the best lessons in the search for more sustainable engineering design. Even former settlements provide interesting lessons in resource efficiency. Anyway, apart from the circular structural circularity by Corentin Fivet at the EPFL, I believe that the Young Digital Circular Economy Lab at the TU Delft is a very good place to start thinking about digitalization of circularity, where the end of life of one building can become and be coupled with the start of life of another. Also, I am an avid reader of some works on AI, trained in architectural and structural design, and I recommend the PhD thesis by a recent graduate from UniMelb, Gabriele Mira, on playfulness and analogical reasoning. And I also suggest the work by Nilich and the very informative Digital Future Events and the excellent studies by Richard Quinn. And yeah, that's my recommendation.
Okay, Sophia, thank you. We've got plenty for our reading list there. We'll have to go and do our homework after this interview. So thank you for sharing those. Well, Sophia, we have reached the conclusion of our interview, and it's been a real pleasure to speak to you today. Thank you very much for giving up your time and sharing the excellent examples of your work per your presentation. For viewers watching this interview, if you've enjoyed this video, or indeed any in the Movers and Shakers interview series, please do remember to like, share, and comment. All of your views and thoughts are most welcome. And do follow Spatial Structures on LinkedIn, Facebook, Instagram, Twitter, and Bilibili. Details of our social channels can be found in the description section of this video. So that just leaves me to once again thank Sophia for joining us today, and reminding us that the Movers and Shakers series is a truly global event. We've got a wonderful guest in Australia today. So thank you again, Sophia, and hopefully we'll get the chance to speak to you again on the series.
Thank you, Mark. Thanks for having me.
See you soon. Bye.
Bye.